Greetings, and welcome to the Galaxy Report. The Galaxy Report is here to bring you intergalactic stories, as featured first at www.dailygalaxy.com. I'm Nicole Butcher, and this week we're going to be diving into the theory that an asteroid crashed into Mars, igniting ancient climate change, resulting in the Mars we know and love today, as well as the mystery that still remains surrounding Mars's South Pole. In the mid-1980s, a group of American archaeologists pored over satellite images, trying to understand what had become of the Mayan civilization that had once ruled over Mexico's Yucatan Peninsula. They discovered a pattern, a near-perfect ring of sinkholes, or cenotes, about 200 kilometers across, encircling the Yucatan capital, Mérida, and port towns of Sinsal and Progreso. A pattern created by an ancient asteroid explosion that one young NASA scientist thought may yield clues to the lost ocean and atmosphere of Mars. When the researchers presented their findings to fellow satellite specialists at a scientific conference in Acapulco, Mexico, in 1988, one scientist in the audience, Adriana Ocampo, then a young planetary geologist at NASA, saw not just a huge ring, but a bullseye. The impact crater of an asteroid that hit with the force of 10 billion Hiroshima nuclear bombs that scarred the planet in ways still being revealed 66 million years later. An impact that ended the reign of dinosaurs and opened a pathway for the emergence of human species. It gave us a leg up to be able to compete, to be able to flourish, as we eventually did, she said. It was perhaps the defining event in the history of planet Earth. University of Washington planetary specialist, scientist Mark Richard, wrote in an email to the Daily Galaxy. Mexico's Chicxulub crater is a natural laboratory because of its similarities to what we can find on other planets, like Mars, where humans can't go, Ocampo said of the debris discovered from asteroid impacts on Mars compared with the ejecta from the Chicxulub crater. The satellite images revealed similarities that indicate that Mars must once have had a much thicker atmosphere than it does now, one closer to the atmosphere that supports life on Earth. It's important for us to know what happened in the past, to be prepared for the future, Ocampo says. It provides a really good insight to what has happened in the geological evolution of Mars. Today, Mars is a frigid desert world, with a carbon dioxide atmosphere 100 times thinner than Earth's. But evidence suggests that in the early history of our solar system, Mars's surface likely hosted an ocean as deep as the Mediterranean Sea. As the planet's atmosphere thinned, however, most of the ocean was lost to space. The remainder of the water is locked up in the Martian ice caps. Astronomers from UC Santa Cruz, Caltech, and MIT proposed that a giant asteroid or comet the size of Pluto, more than 1,200 miles in diameter, sped towards an ancient Mars at a speed of 21,600 miles an hour, crashed at a steep slant into the planet about 3.9 billion years ago, and blasted out a huge elliptical scar measuring 5,300 miles across that now forms all of the planet's northern lowlands, while leaving the southern highlands relatively undamaged. An impact so big it has left half the red planet at a lower elevation. If theories are right, it blasted out the biggest crater that any planet has ever survived. It was a convulsion, far bigger than the one that drove the dinosaurs to extinction on Earth. One region of the surface is the huge oval-shaped scar of the impact itself, covering more than a third of the Martian surface, and including all the vast low-lying lands of the planet's far north. The other is the even larger highland region to the south, marked by deep canyons, high mountains, and the remains of giant volcanoes. NASA's Mars Reconnaissance Orbiter and Mars Global Surveyor have provided detailed information about the elevations and gravity of the red planet's northern and southern hemispheres, as well as the images used in this video. The mystery of the two-phased nature of Mars has perplexed scientists since the first comprehensive images of the surface were beamed home by NASA spacecraft in the 1970s. A giant northern basin that covers about 40% of Mars' surface, sometimes called the Borealis Basin, is the remains of a colossal impact early in the solar system's formation, the new analysis suggests. It is about 4 times wider than the next biggest impact basin known, the Hellas Basin on southern Mars. An accompanying report calculated that the impacting object that produced the Borealis Basin must have been about 1,200 miles across. That is larger than Pluto. Researchers speculate that the Borealis Basin, which spans a size on Mars comparable to about the combined areas of the continents of Asia, Europe, and Australia, could have once held an ocean. This would have been in the planet's infancy, before Mars lost so much of its atmosphere, and the ocean either sublimated away or froze beneath the surface. Mars bears the scars of at least 5 giant impacts, including the ancient giant Borealis Basin, Hellas, and Argue. A NASA-funded team at SWRI discovered that Mars experienced a 400 million year lull in impacts between the formation of Borealis and the younger basins. In 2021, NASA's Mars Curiosity rover discovered that the Martian climate alternated between dry and wetter periods, before drying up completely about 3 billion years ago, according to a French-US team, headed by William Rapin. And now for the news of the Caltech team that has been probing a mysterious feature at the southern pole of Mars, where they've found a massive deposit of CO2 ice and water ice in alternating strata. This layer cake deposit contains as much CO2 as the entire Martian atmosphere today, highlighting a prediction of a theory developed by 2 Caltech scientists, with enormous implications for climate change on Mars. That is, its atmospheric pressure would swing in value as the planet wobbles on its axis during its orbit around the Sun, exposing the poles to more or less sunlight. A new study from Caltech suggests Leighton and Murray's theory that direct sunlight on the CO2 ice deposited at the poles leads to its sublimation might just be right. And sublimation is the direct transit of a material from a solid to a gaseous state. Now, a new model by Peter Buehler, who works with Caltech, NASA, JPL, and the University of Colorado, provides key evidence to support this. This model was described in a paper published in the journal Natural Astronomy on December 23rd. In theory, that layering of a massive deposit of CO2 ice and water should not be possible, because water ice is more thermally stable and darker than CO2 ice. CO2 ice, as scientists long believed, would destabilize quickly if buried underneath water. However, this new model by Buehler shows that it could have evolved as a result of the combination of 3 factors. The changing obliquity, or tilt, of the planet's rotation. 2. The difference in the way the water ice and CO2 ice reflect sunlight. And 3. An increase in atmospheric pressure that occurs when the CO2 ice sublimes. Usually, when you run a model, you don't expect the results to match so closely to what you observe. But thickness and layers, as determined by the model, matches beautifully with radar measurements from orbiting satellites, says Buehler. Our determination of the history of Mars' large pressure swings is fundamental to understanding the evolution of Mars' climate, including the history of liquid water stability and habitability near Mars' surface, says Bueller. Mars has a continued variance of equilibrium, which is something Jupiter's colossal 350-year-old gaseous red spot can relate to, although they may be comprised of different elements. This spot was first recognized as having a dissipative structure in 1970 by Aya Priagoni, who defined it as life operating far from equilibrium within its environment. Some believe these structures, like Jupiter's enigmatic vortex, represent a first step on the way to life. Jupiter's red spot can fit both Earth and Mars, which is something I would like to connect as I bring this report all together. As Adriana Ocampo suggests earlier in this report, Mars represents a precursor to what could happen on Earth, and that is why she found the study of cenotes and comet impact zones so crucial. It seems to me that dissipative structures are on the rise throughout our Earth, and as our climate reaches more destabilization, regardless of physical comet impacts, I must connect it to something discussed in prior galaxy reports, which is the invasion of information. Informational comets. To quote Caleb Shariff, on a geological timescale, the emergence of the human dataome, a world built of bits of and for information, is like a sudden invasion by extraterrestrials, or an asteroid impact that precipitates a mass extinction. It's been a pleasure being on the journey with you guys, and I hope you enjoyed today's report. This report would not be possible without the Daily Galaxy's team of Jackie Farharti, astrophysicist and scientist at the American Museum of Natural History, Avi Shapur, research scientist at MIT. Special thanks to NASA, JPL, Caltech, and the University of Arizona for the amazing images of Mars. I'm Nicole Butcher, and make sure to subscribe. And feel free to check out more breaking intergalactic stories at www.dailygalaxy.com.